Chapter 4, Lesson 1, Solving Systems of Linear Equations in Two Variables. The first thing we're going to do is determine whether a given ordered pair is a solution of a system of linear equations. So what we're going to do is we're going to substitute the x and y coordinates into each of the linear equations. Then we're going to solve each linear equation to determine if the ordered pair makes both equations true. So for example, determine whether the ordered pair is a solution of the system. So for letter A right here, I have the ordered pair -1, 1. So -1 is my x, +1 is my y. And I have to check it in both equation number 1 and equation number 2. So using substitution, the top equation will become -1 minus 2 times 1, and I have to check if that's equal to -7. The bottom equation would be 2 parentheses -1 minus 1, and I have to check if that's equal to -3. It has to be true for both, otherwise it's a no. On the top one, when I simplify the left side, -1 minus 2 times 1 is only -3. It's not -7. So regardless, even if the bottom equation is true, because the top one is not true, the answer is no. They have to both be true. On B, my x is -2 and my y is 3. So redoing the top equation, it would become 5 times -2 plus 3 times 3 needs to equal -1. And the bottom equation is -2 minus 3 equals 1. This would become -10 plus 9, which is -1. So that one is true. This becomes -5 equals 1, which is not true. So again, this is no. X and y on number 2a becomes -3 minus 4 times -1 needs to equal 1. So -3 plus 4, 1 equals 1. That's true. Check the bottom one. 2 times 3 plus -1 should be 5. 2 times 3 is 6 plus -1. 5 equals 5. So we found our first yes. Okay, the second part of today's homework is going to be solving a system of linear equations by graphing. So when we are solving systems of linear equations, basically we're checking for where do the two cross. And now we have two options. We can have two lines that cross once and have one intersection point. So we would have one solution. We can have two lines graphed together that are parallel. And so there is no solution because they don't cross at all. The other option is when we graph the line, they end up graphed on top of each other. So then this would be many solutions. So before we graph them, they must be in slope-intercept form. And then we're going to graph them on the same coordinate plane and see where they cross, if they cross. So for example 3 here, I have x plus y equals 2. And before I graph it, I'm going to change it into y equals -x plus 2. I'm going to subtract the x to both sides. So the slope then would be 1, -1. And the intercept would be +2. So I start at 2 and go down 1 over 1. And there would be the first line. For the second one, I'm going to change it into y equals 3x plus 2. When I do my work to get y by itself, I would subtract 3x first, divide everything by -1. So my slope is 3 over 1, and my intercept is also 2. So right when I graphed my intercept, I already found where they crossed, right here. And so I write that down as the solution. The solution is at 0, 2. On the second one, I have y equals 5x plus 0. So I'm going to start at 0 and go up 5 over 1. And then fill that in. Oops. For my second equation, I'm going to have to subtract 2x to both sides. So my slope is negative 2 over 1, and my intercept is 7. Down 2 over 1, down 2 over 1. And I found out where they crossed already. So they crossed right here. And that solution is at 1, 5. Okay, so I already kind of talked about the solutions, but here's some definitions for the no solution, many solution, or one solution. So if the two lines are parallel, like this example here, when you graph them, they do not cross. The lines have no solution, which we already wrote down. And the definition of that then is called inconsistent equations. If the systems of equations has at least one solution, so like these two examples that we did right here, we call them consistent equations. And if the systems of equations are graphed on top of each other, we call them dependent equations. So as you're going through, if you find a no solution or a many solution, the back of the book might say it as consistent or dependent. So just know what those mean. Write them down so you know what those mean.